So to continue on with parallel and perpendicular lines, we're going to continue on with what we talked about yesterday. So yesterday we talked about graphing parallel and perpendicular, but before we did that, we kind of really had to talk about what does parallel and what does perpendicular mean. So if there was anybody out there, this is just that was absent, a quick little review. We determined that parallel lines are two lines that will never intersect, but perpendicular ones will intersect. But in addition to intersecting, there's one more condition it has to fill, and that means they have to form four right angles. So this is what parallel lines would look like. This is a symbol for parallel. Line A is parallel to line B. And we know from yesterday's activity that if they're parallel, we can guarantee that they would have the same slope in slope-intercept form, right? We learned that when lines are perpendicular to each other, the relationship with the slopes is a little more complicated, right? Okay, but there is definitely a relationship. They have opposite reciprocal slopes. So, and this is the sign for perpendicular. The x-axis and the y-axis are perpendicular to each other. This is just a pair of intersecting lines. And this is, and the whole point of this lesson yesterday, and I know we did a packet, and we just kind of are going to ignore that packet for now because this is better. How does this affect our slope? So if I have an equation that says, hey, here's a line, it's 2/3 x minus 6. Give me some lines that are parallel to that line. And all you have to do is say, as long as the slope that you give me is 2/3, 2/3, 2/3, I don't care what the y-intercept was. Because as long as the slope was 2/3, you can guarantee it's parallel. The only thing that it does is shifts where it touches the y-axis. Did you get that from yesterday? Good. Then I shifted over here and said, okay, here's a line. Give me some lines that are perpendicular to that line. You can't use 4/5 because that would make it parallel. So perpendicular to that line, as long as you give me a line that has a slope of -5/4, you can guarantee it's perpendicular. I don't care what the y-intercept is. Throw any number down there that you want, okay? So did that make sense for you? Okay? And then the other thing we talked about was the horizontal and vertical, right? So I kind of made this little, did we do this in here? Okay? So but right off the bat, by default, every horizontal line and every vertical line are parallel or perpendicular to each other, correct? If this is a y equals line, the only way to get another perpendicular or parallel line is to make it y equals, right? So y equals is parallel to another y equals, which is parallel to another y equals. But perpendicular to a y equals is an x equals. You with me? Okay? So we kind of created this little handy dandy chart that said if I give you a y equals and I ask you for an equation parallel to it, you know it's got to be another y equals, right? Okay? If I give you a y equals and say, okay, give me a line that's perpendicular to it, then perpendicular to y equals would be x equals. So in math and in algebra, there's a lot of computation and steps, right? This isn't any type of steps. This is logic, right? This is just requiring some thinking. So you have to think about it. There is zero work to show for these types of problems and zero calculations to do. You just have to know that a y equals line is parallel to a y equals line, but it's perpendicular to an x equals. Got it? So for x equals -4, if I want something parallel to it, then it's got to be another x equals. Common sense says that. And if I want it perpendicular, it's got to be the other one. So that's kind of a quick little review of what we did yesterday. Okay, so now how do today's notes differ? It has everything to do with this number today. Remember yesterday how I said, just pick one. Whatever y-intercept you want, just throw it down there. -100, +10, 4.1. So it's all about the y-intercept today. So that's the difference in what we're going to start. So go ahead and title your notes, writing equations of parallel and perpendicular lines. Okay? So this is part 2 for parallel and perpendicular. And today we're going to actually write equations. Okay, bless you. So you know how the last section we did was graph it, graph it, graph it. Today it's write it. Write it. So write the equation of parallel, perpendicular abbreviate that, lines. Okay? And I know we did that yesterday, but we're doing it to a further extent today. So, here's how the directions are going to start out. So, you're going to write this one time. It's going to say, write the equation of a line that is parallel to a given line and passes through a given point. I'll give you a minute to write that. So know that you see the word given twice. It means I'm going to give you a line and I'm going to give you a point. And that's all you're going to need to do what I'm asking you to do. Okay? So basically it's going to say, this is what it's going to look like. It'll say, number 1, I want you to make a line that goes through this point and is parallel to this equation. Okay? So that's what your directions are going to look like. Make it write the equation of a line parallel to this line. But oh, by the way, and I know what you're thinking. You're like, oh, y equals negative 4x minus 6 plus 2, da-da-da. No, you can no longer just pick that number anymore. Because let's think about this. If I have this graph right here, and the graph of this line is negative 4x plus 1, there's my plus 1. Here's my down 1, 2, 3, 4 over 1. Here's my line, right? Okay? I want it to pass through this point right here, positive 2, negative 1. So you know what's going to have to change? Not the slope, but the y-intercept, right? So you can't just say minus 6, because then it's not going to pass through that line. So we can kind of take a guess. Well, the point 2, negative 1 is right here. It might look like the new y-intercept might be, somewhere above 1, but we don't know right now because this is not a really good graph. It's just a sketch of it. And unless we have official graph paper, it'll be hard to figure out. So we're going to use algebra instead of graph paper. So here's what you have to do. So the first thing you say is, okay, well, if the line she wants me to write needs to be parallel to this line, I know I better use negative 4x as a slope. And guess what? Right now, that plus 1 means nothing to you. I don't need to know anything about it. You don't use it, so just kind of maybe put a little x to it. It was given as part of the equation, but I don't need it for my calculations. Here's why. So, y equals negative 4x. That part I know. What I don't know is, what does that new y-intercept need to be now that I don't get to just pick it anymore? So guess what it's going to be? It's going to be b right now. Okay, it's the unknown that we need to solve for because that's what algebra does. When we don't know it, we solve for it. So now what do I do with this equation? I have 3 variables, an x, a y, and a b. I need to know the b, and if I know 2 of the other values, can I plug them in and solve for b? Yes. Here's the tricky part though. This is the x and this is the y. A lot of kids will just put them in order. They'll put the 2 here and the negative 1 there because they do it in order, and that's not true, right? Because the y is negative 1 and the x is 2. So when you do this, you have to kind of make sure you put this one here, but then that one goes over there. So watch as I substitute this in. I'm going to say y is negative 1 and x is 2. And when I figure that all out, I'll know my new y-intercept. So I use some little baby algebra skills that we learned a long time ago. Maybe even in 6th grade. The opposite of subtracting 8 is adding 8. And positive 8 plus negative 1 is 7. And 7 is my new y-intercept. It has to be 7. Because if it's not going to go through that point, right? So I'm not done. Because my done is a big final product. Because I need to go back and ask myself, what did Mrs. E just ask me to do? Oh, she asked me to write an equation of a line parallel to this line with this point kind of weaved into it. So what's my final product going to be? Y equals, if it's parallel, it's got to have what? The negative 4x, and then my new y-intercept has to be 7. Are you with me on that one? So we just kind of factor some things in. So now let's do another one. The next example is going to be, okay, I want you to make it go through this point, 4, negative 2, and I want it to be parallel to this line, y equals 1/2 x plus 7. So let's do this whole process again. And we take notes for a purpose so that we can go back and relook. So if you need to relook at your notes, then go back up. Okay, so the first thing I do is say, what piece of information do I need from the given equation? Just the 1/2. I don't need this plus 7. I just need to know what the slope is so I can use that same slope. All right, so she wants it parallel, so I better use 1/2 x. And what's the new y-intercept need to be? I don't know, but I'm going to find out. And all I need to do is plug in the x and the x and the y for the y and solve for b and then write my equation. So let's do that. So let's make y negative 2. Let's take half of our x value, which luckily is an even number. That'll be okay. Although I'll show you when we deal with fractions, it'll be fine. Half of 4 is 2. And then I subtract, and these equation skills should be strong. And then that's your y-intercept. You're not done though. I didn't say what's the y-intercept. I said what's the equation. The full equation of a line parallel to this line, passing through this point. What's it going to be? What's my final product? Well, if it's got to be parallel, I better use 1/2. And my new y-intercept has got to be negative 4. Thumbs up? Okay? All right. So that brings up a really good point. What would you do if I said make it parallel to this line? What's the only thing that I need in this equation? That. And parallel means use the same. So you're using 1. If the slope is 1, then you use 1. Okay? It's going to be a little different is when that pops up for perpendicular. So let's see what happens when we pop up for perpendicular. So this time I want you to make the equation of a line that goes through the point 6, negative 1. And this time I want it perpendicular to this equation. Okay? So one thing is different, one thing is the same from what we just did. So Mrs. E says she wants it perpendicular to this line, which means when I go to set up my equation, what should I use as my slope? Not 2/3, negative 3/2 from yesterday, right? So I'm going to use negative 3/2 here, and then I'm going to put my plus b, and everything else is the same. Did I even need that minus 4? No, it means nothing to you. Okay? So now I plug in my negative 1 for my y and my 6 for my x. Negative 1 is equal to negative 3/2 times 6/1 plus, I don't know, but I will know in a minute. Fractions. Oh, goodness. Let's talk about multiplying fractions. It still keeps popping up. If you can cross cancel. If you can't, multiply numerator times numerator, denominator times denominator, and then simplify that. Okay? So, what is that going to give you? Negative 9. If you would rather cross cancel, then make that a 1 and make that a 3, and there's your negative 9. I don't care how you do it. Just try to calculate it correctly. Let's solve for b. The rest, you know what to do. 8 is your b. I'm not done, though. What is my final product? Okay, you want to know what I give you guys every year or every lesson? I try to tell you the biggest mistake made last year was this, so that you don't make that mistake. I have a lot of kids who do this all perfectly. They change this to the reciprocal. They use it, but then when they go and they write their equation, they put y equals 2/3 x plus 8. I'm like, well, why are you using 2/3 x? Because we did it for the other side. Well, yeah, because those were lines that were perpendicular. Once you, and this is going to be my hint to you, because your answer is not going to be 2/3 x plus 8. It's y equals negative 3/2 x plus 8. Because once I find the opposite reciprocal, that's dead too. I don't need that. And now after I find the opposite reciprocal, I don't need that again. So don't put that in there. I don't know why, but every year, handful of kids will actually go ahead and put that back there. I don't want a parallel one. I want a perpendicular. Are we okay so far? All right, let's say it goes through. And then we're going to show you a few special cases, and then we're done. Negative 1/4, and I want it perpendicular to y equals 4x plus 3. So the first thing I do is I look to see this word. If it's parallel, I'm going to put 4. If it's perpendicular, I'm not going to put 4. I'm going to put what? Negative 1/4. So I'm going to use negative 1/4, and then it's got to be a very specific y-intercept. The days of choosing and picking whichever one you want are over. It's all about the y-intercept right now. Okay? So my y is 4 and my x is 1, which creates not a huge problem because I'm going to give you a little tip here. Man, that would be nice if I could just cancel out that 4, make it a whole number. But so what? Negative times negative is positive, and 1/4 times 1 is 1/4. But guess what? 1/4, when I subtract it from both sides, I don't want to have to deal with subtracting a fraction. Would it be easier to take a quarter away? Isn't 1/4 a quarter? Do you know why we teach you these things in 6th grade and 7th grade and 8th grade? So you can convert things, fractions to decimals and decimals to fractions? Because what would you rather do? Would you rather take a quarter away from $4 or 4 minus 1/4? I mean, neither one should be too hard, but isn't it easier to work with money? I feel like, at least for me, it is. So this is 3.75. That's my new y-intercept. And so when you go to write your whole equation, be careful. I probably should have done this. This didn't matter from the beginning. This doesn't matter anymore because now that I turned it into that, I don't need that. And when I see a big X through it, I'm not going to be tempted to write it. And my final answer is negative 1/4 x. And then you can put plus 3.75. You can put plus 3 3/4. I don't care. This is algebra. I know that you know what that number is supposed to be and that there's an equivalent to it. Okay? What if I asked you to write the slope of a line perpendicular to that? People are instantly confused because perpendicular is opposite reciprocal, but it's a 1. And what's the reciprocal of 1? 1. Because 1/1 is 1. So when I go to write my equation, it's going to be not y equals x, but y equals at least a negative x. So if you can't do the reciprocal of 1, because it doesn't change anything, you at least have to do that, right? Okay? I got one more thing to show you, and then that's it for today. So let's talk about how this affects our horizontal and our vertical lines. And every year, the people get the easiest problems wrong. This problem that I'm about to show you requires no work, no figuring out. It's super, super simple. So if I were to say, I want you to write the equation of a line parallel to y equals 5, and I need it to go through the point 2, negative 6. All right. 0 work. You should, if you understand or if you understood this, you should be able to go boom, write an answer, and move on. Yet these are the easiest ones, but they're the hardest ones that people get wrong. Go ahead, Alex. Yes. So let's think about this. Here's my graph. Here is y equals 5. 1, 2, 3, 4, 5. This is y equals 5. I want it parallel to y equals 5, so it's got to stay horizontal. And the only way to write a horizontal is by a y, but I need it to go through the point 2, negative 6, which is way down here. So if it's got to stay horizontal and go through that point, what's the name of this point right here? y equals negative 6. Do you have to draw a graph every time? No, you just have to look at the point. What is the y? If you want it parallel, then it's got to be a y equals, so look in the y spot. Done. That's it. That's all you have to do for these. So if I were to say, give me a line parallel to y equals 7, but goes through the point 3, 9, what's it got to be? What's parallel to a y equals? Another y equals. Oh, and what's y? 9. So you mean y equals 9? Yup. Okay, let's do perpendicular now. I want it perpendicular to a y equals 3, and I want it to go through point 8, negative 2. What kind of a line is perpendicular to a y equals line? An x equals line. So you mean I can't write y equals? You can, you'll just get it wrong. X equals, oh, and what does x equal now? So I just put x equals 8 and I'm done? Yeah, that's it. Because if this is point 8, negative 2 right over here, and I want it perpendicular to that y equals line, then isn't the name of this line x equals 8? And doesn't x equal 8 right there? That's it, guys. That's seriously it. So if I say perpendicular to x equals 4, and I need it to go through point negative 5, 0. I need it to be right there on that x-axis, but perpendicular. So what would this equation be? Y equals 0. The hardest part is people go, oh, they walk up to my desk and they go, I don't know whether to make it y equals or x equals. And then I tell them, because you're trying to memorize it, not understand it. If you try to understand it, doesn't it make sense? Perpendicular, it is horizontal and vertical to each other. If this is an x equals and it's perpendicular, then it's got to be the y. Make y equal to 0. Got it? That's all there is to it. Okay.